Let's start with a robot class that has a private integer field that stores the robot's IQ. Now let's give it a constructor that initializes this private IQ field using an integer argument. One thing to note about constructors in C++ is that they actually do double duty. Not only do they allow us to create an instance of the robot class, for example, in this situation, like so, they also serve as a blueprint for implicit conversion, meaning conversion from the integer type to the robot type. To see this, we can actually replace this instantiation of the robot class with the following assignment. We see here that we have an implicit conversion from the integer 70 into an instance of the robot class called Bender. Now a question arises as to whether or not we can chain multiple implicit conversions together. For example, let's say we have a drone class with a constructor that serves as a blueprint for implicit conversion from robot class to drone. Remember, we also have an implicit conversion from integer class to robot. The question then is, can we expect to have an implicit conversion from integer type to drone type through the robot type? To find out, we can try to create an instance of the drone class the same way we created the instance of the robot class here. And we see here that we get an error. No suitable constructor exists to convert from integer to drone. So even though we have a suitable conversion from integer to robot and from robot to drone, the compiler is unable to chain these two together to allow us to convert from int to drone implicitly. So the answer is no. In order to fix this error, we have to remove the need for one of these implicit conversions. In this case, we can remove the need to implicitly convert from robot to drone by explicitly calling the drone constructor, like so. So within the parentheses here, we do have an implicit conversion from integer to robot, but we now have an explicit call to the drone constructor, which takes this robot and from it constructs a drone. Note that we can disable this double duty feature of C++ constructors by placing an explicit keyword before the constructor. This disables use of the constructor as a blueprint for implicit conversion, and we now get errors in these two statements. Let's revert back to allow implicit conversion. Now, just because we can rely on implicit conversion doesn't mean we always should. The goal of this statement is to create an instance of the robot class. And by explicitly calling the constructor of the robot class, this goal is clearer and it is concise enough. You should make these decisions on a case-by-case basis. C++ also differs from other languages in that you cannot declare a class variable without instantiating it at the same time, meaning you cannot declare it on one line of code and then instantiate it on another line of code. Let's look at an example. Here we have a position class that has two private float variables, x and y. Let's give it a default constructor. This default constructor will initialize x and y to 22. Let's also give it a non-default constructor, which will initialize x and y using two input arguments. Now, if we declare a position variable, like so, this line of code will create an instance of the position class by calling the default constructor, since we have not passed any arguments on this line. In fact, if we comment out the default constructor, the compiler will complain, knowing that this line of code requires a default constructor and we don't have a default constructor. And if we uncomment and run this code, we will see that once it gets to this line of code, if we hit continue, it will take us into the default constructor. And if we hit continue again, we will see that it has finished constructing an instance of this class and it has initialized x and y to 22 as specified in the default constructor. Now you can run into situations where this type of behavior is not desirable. Specifically in our case, if the position variable were a member of another class, let's say a robot class, and we wanted to initialize this member variable in the robot's constructor. Our goal here is to instantiate the position variable once but we end up calling a position constructor twice. Once on the line of code that declares the member variable, and this one calls the default constructor of the position class. And then again inside the robot constructor, we call the non-default position constructor. This is wasteful from a performance point of view. How do we tell the computer, as it were, to not call the default position constructor when we declare the position member variable on this line? And the answer is to initialize the position member in a member initializer list instead of initializing it inside the robot constructor. And the member initializer list looks like this. It's placed right before the opening braces of the robot constructor, and it starts with a colon, followed by the name of the member we wish to initialize, followed by constructor arguments in parentheses. Of course, we can include multiple members in our member initializer list. Right now, our robot class only has a position member, so let's give it an altitude member. And we add it to the list simply by writing comma, followed by the name of the member. And in parentheses, we pass the value that we want to initialize this integer to, in this case z. Note that the order in which we specify the initializations in the member initializer list matters. It needs to match the order in which we specify the members in the declarations. And when constructing the robot, in this case, the position will be initialized before the altitude will be. Finally, newcomers to C++ may be averse to this member initializer list notation because I'm sure it looks very alien to them. But I do encourage newcomers to embrace it because it is favorable from a syntax point of view as well. It allows you to separate the part of your constructor code that is strictly initializations from the rest of what you might do in a constructor.